Okay, so as you might have imagined, most of the air pollution that we comes from burning stuff. The main thing we burn is fossil fuels. You might not realize this because of the fact that you don't see the gasoline burning inside the engine of your car, and you don't see the coal or natural gas or sometimes diesel fuel that's burnt at the power plant. But that's the thing that we burn the most of. Otherwise, what do we burn? What do you think of that you might burn? You know, nothing illegal, please. I don't want to hear.
Wood.
Wood, yeah, burning wood, right? So I'm going to go ahead and take deforestation because that typically involves burning wood. But you burn wood. What else could you burn? Just to get rid of it. Paper. Yeah, burn some paper. Maybe some leaves and stuff, right?
Paper's kind of wood, isn't it?
Yes. Well, we're gonna get to that, but you're right. It's used to be wood. Poop. You can burn poop. You ever burn poop? Yeah. It's not a good idea if you get the wrong kind of poop. You really want to only burn herbivore poop. But dung has been used for centuries as a source of fuel. People living in nomadic societies that raised cattle and stuff like that, that was their livelihood and everything. That would be in the grasslands. There's not a lot of trees in the grasslands, so there's not a lot of wood for fuel and to bake stuff or keep warm or whatever. But there's a lot of cow chips lying around. They are high in fiber content, and they actually make a very good fuel. So all those together have a name. These are all recently living substances, even the poop, and we call that biomass. So yeah, it's just generally living, and mass is just matter, tissue, etc. And a lot of times they do actually have a weight value component to them. We talk about biomass a lot of times. That just means recently living materials as opposed to fossil fuels, which are ancient biomass. And fossil fuels are different. And we'll talk about this in the Energy Resource Unit, but they are chemically different than a piece of coal is chemically different from a piece of wood from the compression and everything over the years. But otherwise, those are the main things that we burn are organic substances. And living organisms and therefore organic substances have certain elements in common. One, of course, is carbon. Everybody knows we're carbon-based life forms, the backbone of our proteins, fats, carbohydrates, all carbon. Also nitrogen. Nitrogen is an important complex, important element, in proteins. And oxygen. The other one that ends up being a gas is sulfur. Okay? Sulfur. Now, there's a fourth one, which is almost in great amount in our bodies as sulfur, and that's phosphorus. But phosphorus, when it burns, does not form a gas. All three of these are gases. And you might notice that we've got an X here, and that is because a lot of times the number of oxygens that are on there can vary. And of course you know that when something burns, what element does it react with? What element is common amongst all three of these? Oxygen. Okay. So consequently, that's what's going to be in there. And so when you burn something, whether it's some coal or whether it's a squirrel or whatever, those things are going to react with the oxygen that's in the atmosphere and form these oxide compounds. Okay. And as we shall see, these have some interactions in the atmosphere that affect the environment. So anyway, like I said, the X means that, for example, this could be one N, one O. It could be one N and two O's. It could be two N and five O's, etc. So those are all possible compounds from there. Carbon, we of course know carbon dioxide. Now I have mentioned that carbon dioxide is kind of so-so as far as being an actual pollutant. It is implicated in global climate change and things, so some people call it pollutant, some people don't. Doesn't really matter. But it has an evil cousin that is definitely a pollutant. Anybody know what carbon dioxide's evil cousin is?
Carbon monoxide?
Carbon monoxide, correct. Carbon monoxide. Many people die every year from carbon monoxide poisoning. And then sulfur oxide is, we'll talk about one of these, what the different environmental facts, what they do in the atmosphere as well as we move along. But that gives us a nice little mnemonic device here of NOx, COX, and SOx. Come on, say it with me, folks. Knox, Cox, and Socks. That was weak, but I'm not going to do it again. All right. What else do we get from burning stuff, or just in general? Other types of air pollution. Another big category of air pollution is something called particulate pollution, which means that it's made out of particles. Okay. One of the most common types of particulate pollution that does come from burning stuff as well, and this is what you see when you see black smoke. If you see white smoke, that's usually just water condensing, water vapor condensing. It's steam. But black smoke is unburnt carbon particles. So it's in the fire or whatever else, it's burning, but it's not quite hot enough to burn to burn the carbon itself. It just burns the stuff off the outside of the different elements off the outside. You have these little tiny, almost microscopic, they're not quite microscopic though. This is what you commonly call soot. Like if you burn something, there's something over it, like a candle or something like that, and you burn it, and you see that black stuff on there, that's the little bitty bits of carbon that make that up. Dust is a particulate pollution. Dust can have a number of environmental effects as well as a number of health effects, and therefore is a pollutant. Even pollen. Pollen's good for the environment, right? That's how trees get baby trees and plants make other plants, right? So that's a good stuff thing. Why is it considered a pollutant? What do you think, Cassie? That pollen is considered a pollutant. Second. Anybody have any ideas out there? Melina? Come on, that was a hand raise, right? Even though you're probably just adjusting your hair. Okay, so we said that it's a pollutant if it either has a negative effect on the environment, the health of the environment, or the health of people. Thank you. Okay, so what does pollen do? Yeah, see, allergies, asthma, it can be fatal. Asthma is a fatal disease, or is a potentially lethal disease. So, what do they call it? Yeah. So, anyway, there's particulate pollution, many different forms of that, as you can imagine. These up here, by the way, these are gases. They're separate molecules when they go off in the atmosphere. So these are not, they're bits of matter, so they're much, much bigger as far as the size of them goes. Another molecular kind of pollutant that gets in the air is something we call VOCs, or volatile organic compounds. These are vapors and fumes, gas fumes. Nail polish remover, flatulence. These are all volatile organic compounds, and they have been shown to have some health effects, negative health effects, long-term exposure, linkage to both cancer and liver damage. But the thing about it is, if you smell something, the molecules of that substance have gotten into your nose. And therefore, you are exposed to it. It's going to be absorbed into your body from there, so you're exposed. And think about that next time your friend lets one around, and you're like, ugh, you know, their butt molecules are in your nose. So, sorry about that. Alrighty. Now, these are all what we call primary pollutants. Primary pollutants, because they come right out of the source. When you burn something, these are going to come right out, the soot, all that kind of stuff come right from the source. One of the things about air pollution that's a little bit different than water pollution is that in a lot of instances, the air pollutants that come out that we call primary pollutants will interact either with each other in the atmosphere and form other worse stuff, or they will react with water in the clouds. And this is where we get acid rain from. So those other pollutants that are formed after that are called secondary pollutants, for obvious reasons. Okay. One of the most common examples of secondary pollution formation is a substance called photochemical smog. And this happens in cities that have a lot of traffic. And there's a reaction that takes place between gasoline and diesel fumes, that's your VOCs, coming out with all the traffic in the morning and everything. You also get from automobiles, you get nitrogen oxides. Inside the cylinder of an automobile and a truck, the compression and the heat and everything causes the nitrogen and oxygen to react together, and that's why you get nitrogen oxides. There's not that much nitrogen in gasoline or anything, so that's how you get a lot of your nitrogen oxides. Those two substances will, in the presence of each other and then catalyzed by sunlight. That's where we get the photochemical smog. So you can picture big city, morning rush hour traffic, all that exhaust in there, all the fumes from the gas tanks and stuff in the air. Sunlight comes out, beats down on it, it changes these things. And what it does with it changes these substances into, actually there's like 100 different compounds, all right, and many different steps. Very complex process. We're only going to scratch the surface of it in here. I don't know most of it, and a lot of the ones that I've seen reactions where I don't understand them either. And I have a minor in chemistry, so very complex. So some of the main things that it makes that are much worse than the original, the primary pollutants, are ozone, peroxyacetylnitrates, nitrates, and hydrogen peroxide. Wait a minute, I thought ozone was good, right? Isn't ozone good? We just talked about that, right? Ozone good.
You said it.
Ozone not good?
You said you didn't want to breathe it in.
Ozone bad. Ozone good? Bad?
Yes.
Good up here, bad down here. Good down here, bad up here? Which is it? Yeah. Ozone is a strong, you're right, Andrew. I said it's good in the upper atmosphere when it forms because that blocks UV radiation. Just finished talking about that. But ozone itself is a very strong, powerful oxidizer, nasty chemical. You may also remember, we mentioned it when we talked about, what? Does anybody else remember that? Paul David? Huh? When else did we talk about ozone? Huh?
Is this my time for the cameo?
It is time.
All
You're
right.
up. That's your cameo appearance there.
All right.
Impress us. When else did we talk about ozone? I'll give you a hint. Is when we were in the water unit. What was it used for? You remember?
I remember. I don't remember.
You don't remember. Pass it off.
I'll give this a
Zach.
I don't know.
Pass it to somebody else. Anybody? Remember? Andrew. Thank you. Actually, Andrew, that's a lot. David. Thank you. Purifying water, same as like chlorine, ultraviolet radiation. It's a strong oxidizer. Not only does it kill microorganisms like bacteria and viruses, it breaks down organic materials so more stuff doesn't grow on top. All right. Peroxide, also use peroxide to disinfect a cut. What's peroxide do to your hair? Makes it fall out. That's what happened to me. No. It's for the bleach. It's a type of hair bleaching mechanism, just like chlorine. Strong oxidizer. You don't think of it as so bad because you get the 3% solution. 50% hydrogen peroxide will peel your skin. So anyway, those are secondary. That's one example of secondary pollutants. We'll look at some more when we look at acid rain, which will be on the next slide, which will be next week. Okay. Any questions about secondary pollutants or photochemical smog? I have a diagram. You're not going to have to know the details, but you're going to have to know most of what I put here, so you're going to have to commit that to memory. Okay. And then also another category of pollutants are indoor air pollutants. So as I mentioned, negative effect on the health of the ecosystem or negative effect on human health or both. These, of course, are not really going to affect ecosystems, except your indoor plants and stuff. But they affect us. They affect human health, of course. So one of the main ones is radon. Radioactive gas, that's an O by the way. Radioactive gas, it's part of the decomposition of uranium. It's common in areas where you have a lot of granite in the bedrock.
That's capital R-A-D and lowercase o?
No, it just, whatever, it doesn't, it'll...
I didn't know if it was...
On the test, you can choose it, but that's just my,
I don't know if
you know
it
how I
was
am.
an acronym or something.
It's my bipolarism that's coming out. So the radon is a naturally occurring substance. Under normal conditions, it seeps out of the bedrock, particularly if you have a lot of granite in your bedrock, which we do not, so that's a good thing for us. But it doesn't really harm anything under natural conditions. However, people build houses and buildings, office buildings and stuff, with basements. And a basement is a natural collecting chamber. If that basement is down in granite-type bedrock, or there's some other ones that have a lot of radon in them too, to collect those together, and you stay cooped up in that building, whether it's at work or at home. If you don't ventilate a lot and things like that, then you get long-term exposure it is considered to be the second leading cause of lung cancer. So it's serious. It's pretty far down from cigarettes and other types of combustion products in that category, but it is a serious problem. Speaking of cigarette smoke itself is considered to be an indoor air pollutant.
Is that how you smell cigarettes?
I don't know. I don't smoke.
Yes.
That's not how you smell cigarettes.
I'm
I
pretty
think it
sure
is.
Yeah, I'm pretty sure it is.
Cigarettes.
Yeah, that's how you spell it.
Yeah, I think
What'd you say, Smokey?
No, it's-
Sorry.
I'm gonna put C.
Yeah, whatever. You know what the word is. I am spelling impaired. It would not be the first time I made a mistake.
Or put
On here.
tobaccos.
What's that one before?
Good point. Yeah, actually, that would be more accurate because it could be cigar smoke or whatever. So anyway, also, you know that new car smell or new house smell or whatever? Love it, right? That's cancer causing. Sorry. Yeah, that's why I haven't bought a new car in 15 years. So yeah, those are. There's chloroform in there, formaldehyde, a lot of different things. Not high quantities. Obviously, if it was considered to be a serious health effect, they would somehow ban it or use alternative materials. But it's there, and so that is also an indoor air pollutant. Questions? Anybody? I guess not, because they're all packing up, ready to go. That's great. Love you. Okay. So, now we're looking at the effects. We've already talked about the sources of air pollution. Now we're going to look at some of the effects, both environmental and health-wise. And I would not want to minimize the effects that air pollution has on the environment, but there's really one major tangible type of air pollution and process that specifically affects the environment quite a bit, and that is the formation of acid precipitation. Okay? One of the reasons for this is that a lot of the air pollutants either settle out or dissipate into the atmosphere before they even get really much outside of the city. And of course, your cities are your biggest sources for these air pollutants typically. Although we are seeing quite a bit with the increasing amounts of destruction of the rainforest. You're seeing a lot of air pollution type problems in those areas where they're burning down massive amounts of trees and things like that. But as mentioned on the first slide, one of the products of burning both fossil fuels and biomass are nitrogen and sulfur oxides. Your knocks in your socks. Knock your socks off. These particular compounds will form acids when they react with water. They're actually called acidic anhydrides. It's just a chemical property of them, and they will form nitric and sulfuric acids respectively. And so that, of course, is not going to be good for the environment. Now, one of the things that I want to impress upon you is the fact that if you're in an acid rainstorm, the lowest pH acid rain recorded, that you would not really be able to tell. It wouldn't be like you went out there, ah, an acid rain, and it's kind of burning your skin off and things like that. Although that would be pretty cool if we did. It's not that low in pH, and so consequently, you know, we don't particularly feel those effects of being in that level of acidity. But it definitely changes the soil chemistry and also changes water chemistry in bodies of surface water. And as I think we learned, I think I mentioned way back when we were talking about water chemistry and things, water pollution, one of the things that acids do is that they dissolve minerals. Minerals that normally would not dissolve in water will dissolve in acids, or they will dissolve in more acidic water. And so, first of all, that effect when that acid rain or acid precipitation lands on the ground, on the soil, is that it's going to make those minerals in the soil more soluble, and then be more able to be washed out. And of course, that means that those minerals are no longer going to be available to the plants that are in there. But it also means that those minerals are going to go where? Where are those minerals going to end up? Well, water, rain comes down, precipitation comes down, and it hits the ground, and then where does it go from there? It can soak down to the ground. It may evaporate. Remember three things. or may become runoff, right? So it's going to make its way down into bodies of water, okay? So if and when that happens, I should say, those minerals are going to go with it, minerals that can fertilize the water, which causes what type of process when you fertilize the water? Yeah, eutrophication, okay? So that's one of the problems, and we've already got a problem on land from what it does to the plants. Then you're going to have a problem in the water from those minerals going into the water. And then there is another problem that takes place when there may be in the soil toxic metals, like lead or mercury. They may be naturally there. And therefore, if you have acidic rain, both of those substances are normally not very soluble. But once again, acids dissolve things when they normally would not dissolve. And so they'll dissolve it in there and they will go into the water and actually directly kill fish and other organisms. Also, lower pH, higher acidity levels in lakes and stuff have a number of developmental effects on fish and clams and things like that. They come from there. So not only do you have effects with your terrestrial ecosystem, damages plants and stuff, you're also going to have effects in the water from increased minerals, toxic heavy metals, and just general overall changes that water chemistry has on the physiology of the fish and the other organisms that live there. So acid shock, let's go ahead and make a notation. Acid shock typically comes from toxic heavy metals. All right, so environmental effects, although I don't have a huge number of them to list here, although this encompasses quite a few here, no doubt there is a definite impact on the environment from air pollution, and acid precipitation is one of the most definite ones. Also, it tends to move. This has caused political problems because you can have factories, etc., that are producing air pollution. Now, one of the things they've done in the past, and we'll talk about this later, but one of the things they've done to help combat air pollution is simply make smokestacks taller. Which, you know, as silly as that may sound, it actually helps a lot because it gets the exhaust from the factories and stuff higher up in the atmosphere, and it gets blown away, and it doesn't affect the people in the city as much. But, of course, that means it's going to go somewhere else. So particularly if it gets into clouds, clouds move, and you can see in a lot of areas where you'll have industrial areas where the acid precipitation actually ends up, because of wind patterns and stuff, ends up in non-industrialized areas, and then you're damaging forests and things like that. Canada has kind of gotten, although the United States and many developed nations have cleaned up a lot of their emissions, but there's a time when they were not happy with the fact that a lot of their pristine forests and stuff on the north side of the Great Lakes areas have been affected by the heavy industry and things that we have on the south side of the Midwestern areas of Chicago, Detroit, those areas along the Great Lakes, producing acid rain and then coming down and precipitating there in Canada. Also, the lowest pH, which means the most acidic acid rain, was recorded in the Appalachian Mountains, which are not, in an industrialized area per se, but the wind and everything from there blew them from that industrialized part of the Midwest of the United States. And the mountains there blocked it, so it precipitated out, and that's where you ended up having a lot of that and a lot of damage as well to the forests in those areas. So those are some of the many different things that can happen from acid precipitation. And there's other, not quite as common problems that we get from air pollution. But probably one of the biggest focuses, or one of the biggest concerns with air pollution, is the health effects it has, because they are numerous and widespread. So one of the things you have to realize is that if you have any kind of respiratory problem, asthma, emphysema, tuberculosis, pneumonia, all these things are respiratory problems. All of them will be made worse by air pollution. And all of these things being respiratory problems, they can all be fatal. So it's not a minor thing by any means. Sometimes it's a direct thing. Sometimes you get a sickness, you end up getting pneumonia because of this air pollution, and pneumonia can be fatal, particularly if you're older. Sometimes they're chronic exposure kind of things, like we see here from some of your radon, your VOCs, and it's good, smoke as well. Can cause cancer after long-term exposure to them. So that's another big impact on human health from different types of air pollutants. Carbon monoxide. This, as far as acute poisons, now acute poisons are ones that will kill you right away, whereas of course chronic poisons are ones that affect you over a long-term basis of exposure. Carbon monoxide is definitely the killer that can kill you right away, and there are hundreds, probably thousands of people every year that die from carbon monoxide poisoning. And it doesn't matter how healthy you are. You know, like I said, if you've got respiratory problems, air pollution can trigger, illnesses that could become fatal. This will kill you even if you're, a marathon runner or something like that, or climbed on Mount Everest. Carbon monoxide can kill you very quickly. There's a couple things that make it so deadly. Number one, the way it acts, carbon monoxide is more attracted to, or your hemoglobin likes carbon monoxide better than it does oxygen. So if you breathe a little bit in, it'll actively displace oxygen from your hemoglobin, basically suffocating you. Okay. The second thing is that it is non-toxic. Excuse me. It's toxic. It's odorless and colorless, so you don't know it's there. A lot of these other pollutants, ozone for example, you inhale some of that, you start coughing, gagging, it has a very distinct odor to it, you would know better than to stick around and keep inhaling it. Okay. Carbon monoxide, however, doesn't have any of those properties. Even it doesn't really physiologically cause you, to start coughing and things like that, unless it's very high levels. Small amounts you get in and you breathe it in, it's coming in and out, and you don't know about it, and you get a little sleepy, start to get a headache because you're slowly you're slowly suffocating, running out of oxygen. Go to sleep and don't wake up. Okay, very common thing to happen. Happens whenever you burn something inside that doesn't burn completely, or you run something like something that has an internal combustion engine, like a car or a generator or something like that, in an enclosed area. So don't idle your car when the garage is closed, things like that. But it's a very common cause of death, not only in developed nations, but here, in the industrialized world, people still die all the time. They do make carbon monoxide monitors, so that can be taken care of. Now, you might have noticed, you might be asking, what about gas stoves, natural gas stoves? You've got a little fire going on right there in your house. Same is true with heaters and stuff. That, because of the fuel, the natural gas burns so completely, you get very little carbon monoxide that is generated from that. Gasoline, you get a little more. Actually, one of the worst is charcoal. I think I saw a commercial that talking about charcoal, bringing the charcoal inside. Don't do that; you can burn your house down. Well, more likely, you start burning charcoal inside, you're all gonna die from carbon monoxide poisoning. So before you burn the house down, so anything that does not burn as completely, does not have a nice clear blue flame to it, you're producing carbon monoxide, and it could easily kill you. Okay. So speaking of death, air pollution disasters have occurred in the past. In the 20th century, there have been several of them, and some of them in the 19th century as well. Air pollution has been around since it's been around since we've been burning stuff. But serious amounts of it in cities have been around since the Industrial Revolution. And what happens is you have these air pollution disasters where, for certain reasons, which we'll talk about in the next bullet, air pollutants are concentrated in a city, and you end up getting a lot of people that are checking into the hospital for these problems. And like I said, a lot of respiratory problems are fatal. And so when you have this instance killing, when they say it killed up to 10,000, it doesn't mean that all of a sudden a toxic cloud settled in and people just dropped dead on the street. But what happens is, if you look at your hospital population and you see that the number of deaths from respiratory problems goes up, and it's at the same time period as you've got one of these situations where the air pollution is trapped in the city, then it's a pretty logical conclusion that those extra deaths were a result of air pollution. So we call those, of course, air pollution deaths. And it has gotten so bad in the past, and this was in 1947, they had an air pollution disaster situation which killed about 10,000 people. Okay, that's big. That's a lot. 9/11 killed 3,000 something people. So that's a huge number of people. Fortunately, that that opened a lot of eyes. They did a lot of improvements. One of them was just like I said, just getting smokestacks on factories up and out away from the street level, so the pollutants and stuff don't concentrate there as much. These disasters, however, were most likely linked to a weather type event, a meteorological situation known as a thermal inversion, also known as a temperature inversion. And this happens when you get basically a flip-flop of normal air conditions. What normally happens to the temperature as you go up in the atmosphere? So you get colder or warmer?
Colder.
It gets colder. Okay. Now, I didn't really make it clear, perhaps, the last unit that we talked about, the last section we talked about when we talked about CFCs, ozone depletion, that kind of thing. But we do know that CFCs break down the ozone layer. We do know that has some definite direct effects on both human and ecosystem health. And therefore, I want to make sure we know that that is in this category of air pollutants. And one of the sources of them is improper disposal of old air conditioners and refrigerators. Now, aerosol cans would be an issue in the past, so I'm going to go ahead and give it to you because that does show that the CFC is coming from aerosol cans, etc. But really more so, particularly in developing nations where they're not regulating things, throwing away old refrigerators, they should be, of course, the freon that's in the compressor should be drained out and captured. Typically, I think they incinerate them to get rid of them, so to not release the CFCs into the environment. But that's a source of CFCs that is now still ongoing, even though we've phased out using them for the most part in much of the world. Okay, so I kind of put that in there. It's almost an afterthought. You can see it doesn't really have a bullet there, so but you should know that. Then, of course, like I said, the main source of pollution is burning stuff, combustion. Okay. So when we look at how to reduce air pollution from that, we can look at it really in three phases: before, during, and afterwards. So when we talk about before combustion, we're talking about either using a cleaner fuel or cleaning up the fuel that you have. So let's make a little note in your notes here, maybe in the margin or something like that. And when talking about fossil fuels, we go from coal to petroleum. I'm going to abbreviate it here, PET. Don't burn your pets. To natural gas. Okay, those are your three main types of fossil fuels. And that order is, for lack of a better term, from dirty to clean. Clean, burning propane. So each one of these, as you might imagine, has a little bit, it has to do with impurities. What's in it besides the carbon, the main part. Because, like I said, with carbon dioxide, we're not really considering that in this particular one. Carbon monoxide, yes. But we get a lot of the sulfur oxides, for example, from burning coal. Also, coal being a solid, being a mined substance, it has a lot of other stuff in there with it a lot of times. So one of the particular ones, although it's not in a large amount, the materials that are being put out are bad from the fact they're very toxic, but also from the fact they're very hard to get rid of, and that's heavy metals. Heavy metals, such as, here it is, lead, what else? Even denser than lead, although it's a mercury, it's a liquid. Yeah, mercury. Mercury's more dense than lead. Anybody ever hold up like a jar of mercury? It's like, but toxic heavy metal. And there's high amounts of it in tuna. You might ask, what are these tuna doing? Going and eating old mercury switches or whatever? No, they believe that it's come primarily from coal burning. Because, you know, it's not a huge amount, but every once in a while some of that coal is going to have some mercury ore in it. That gets vaporized and condenses and comes back down into the environment. So same is true of lead, cadmium, any of your toxic metals. There's a chance it will be in coal, even some in petroleum. They now require that diesel fuel, for example, you can actually see this on the diesel fuel pump, to be low in sulfur content because of the sulfur oxides causing acid rain. So that's a little bit cleaner. Natural gas really has very little of any of these impurities in it, so that's the best choice for that. Now you can also take these, like coal and petroleum, you can clean them up. You can take extra efforts to remove these substances from them. With coal, it's a matter of crushing it up and washing it and using chemicals to neutralize certain other chemicals. But that's the before picture. So you can either use a cleaner fuel in the first place, or you can clean up that dirty fuel beforehand to reduce the emissions that they're going to produce, to reduce the pollutants that they'll produce. Okay? And then you have your during. Okay, so this is while it's being burnt. And if you burn substances at higher temperature and with more oxygen, you will produce less carbon soot, carbon particles, and less carbon monoxide, because those are both products of incomplete combustion. So higher temperatures and more oxygen cause for greater combustion of these substances. So that helps reduce it as well. So that's the during. Okay? And then you have the after process. Change it up here. And what can you do to the exhaust? There's a number of different things, and I'll show you some diagrams of them. From just a plain old physical filter of these big buildings filled with basically these paper and cloth bags, they call them bag houses, that they just pump the exhaust from the factory into these things, and it comes out the end cleaner, as you might imagine, particulates at least. Electrostatic precipitation, these are particles that are in smoke. The heat and everything bouncing off each other, they get charged. Just like when you have a volcanic eruption, you'll see lightning all around that eruption because of the charged particles, because they're moving fast and knocking up against each other. And therefore, if you have a charged particle, you can pull it out with magnetic charge. So you have these electrostatic plates, these charged plates that go through there, it pulls along the side. As a matter of fact, indoor air filters, a lot of times they use this. They use charged plates to pull it out. The Ionic Breeze is one of the brand names, the ones that does that. Wet scrubbing. Wet scrubbing is probably the best as far as taking everything else, and as the name implies, you either direct the exhaust through water, bubble it through water, or they spray it. When it's going out through the exhaust, they spray water on it as it goes through, because that will not only take out most of your particulate stuff, the ash and things like that, but it also will react, if you remember back to the previous slide, the sulfur and the nitrogen oxide compounds, and react with the water right there rather than up in the clouds. The only practical problem with that and environmental problem is now you have to dispose of that water that you use to wash the pollutants. It takes quite a bit of water to do it, and you've got a dirty water problem afterwards you have to deal with. But it's one of the most effective ways to clean up air pollution. So those are stationary types of pollution, and it's easier to do those because they're stationary. You can build big buildings for these different things. Automobiles, a little different. Cars, except of course, we'll generalize a little bit more with automobiles to include trucks, etc. Any conveyance, mobile conveyance that burns fossil fuels. And they have a lot of pollution control devices on them. One of the most common is something known as a catalytic converter. but you put it on your car, it'll turn it into a Cadillac. No, it catalyzes the reactions between carbon monoxide, nitrogen oxides, and O2 into, catalyzes them into O2, N2, and CO2. So these are much less polluting problems, if at all, really, all those except for CO2. You're going to get CO2 no matter what. And another one, should be a period in there, by the way, that they did in the 70s, 80s, was they phased out lead. And I don't know if you still, I haven't really looked to pay attention to see if it still says unleaded gas on the fuel pumps. Maybe it does. It does. Were you ever wondering, okay, where's the leaded gas? You know, I want to be able to write with my gasoline. It's not lead, it's in pencils, by the way. But lead was added in the past to, it helps the way the gasoline burns. But obviously, when you burn it, you're putting lead out in the environment. Sometimes it's amazing what we did in the past, which we didn't realize, figure would hurt, because we know lead was poisonous for a long time. So, of course, they found increased levels of lead in roadsides and things like this, and somebody said, I wonder where that's coming from. Oh, maybe it's coming from the gasoline that's being burned along the roadsides all the time. So that has been replaced, phased out. So those are some of the different things on the after side, or this, of course, this actually would be on the before side, before you burned it, by putting a different thing to burn there. Okay. And then indoor air pollutants. So big thing, as you might imagine, ventilation. What did you put there before I
Aeration.
that aeration? Meh. I'll give it to you. I think that's sort of what you meant. Ventilation. And the problem here is that in our zeal to save energy, make buildings more, use less energy to cool and heat them, we've sealed them up. So that's caused problems with being overexposed to these indoor air pollutants. So they have this technology, one innovative technology, where the building will ventilate when it reaches a certain temperature. So like here at night, when it finally gets down to maybe 68 or something, they don't have one here, by the way, I don't think, but in a building like that, then they would open some vents and stuff, and fans would turn on, and it'd vent out the inside air and bring in some outside air. Of course, if you're in an air-polluted city, that's not going to help much, but that's one way. You can also use alternative materials. Remember we mentioned VOCs was a problem? They make products like low VOC paints now and other things. And there's just different materials that don't give off so many toxic stuff. And of course you can regulate people smoking inside and things like that. And then finally, dust. And is dust in the air? Dust in the wind is a type of air pollution. And so if we reduce soil erosion, we're going to reduce that as a form of air pollution. All right? Questions?